thing. I guess it's recording. Okay. All right. So guys, to solve a differential using MATLAB, it's actually pretty easy. I'm going to show you guys how to do like a first order, a second order. So on your exam, tell me a first order differential that was on your exam real quick. I don't care which one. Just not the, I guess not the exact one, because that's then you have to solve it. What was the Bernoulli one? I forget. It was number 3 or 4.
Dy/x equals y times quantity x y cubed minus 1.
Okay. All right. So let's say we wanted to solve that. All right. And let's just throw an initial value just because we can. Let's say y at 1 is equal to 1. Okay. So let me show you guys how to use MATLAB to be able to solve that differential. First thing we're going to do is we are going to start by defining some symbolic variables. Okay. So what I always do is I always clear all and clear the screen. And then I'm going to define 2 variables. I'm going to define x is symbolic and y at x is symbolic. I'm going to define the equation. I'm just going to call it EQU. All right, so that's going to be the actual equation. That's going to be equal to the derivative, which is diff y comma x. Okay, so anytime you guys want to define like y prime or dy dx, use diff yx. That's going to be equal to, and you're going to use a double equal because that's what that's doing is this first equal is assigning the differential equation to EQU. The double equal means it's going to test and it's going to solve that way. Okay, so it's diff, and then we're going to have y times, and then what do we have up there? X times y cubed. Remember, make sure you put those parentheses in, and then it was plus y, I think, or plus minus 1. Okay. And then what I'm going to do is I'm just going to use a dsolve. Okay, so dsolve, and I'll get to the initial value stuff, EQU. All right, so let me run that. And let's see if MATLAB's smart enough to solve it. Sometimes it is, sometimes it isn't. Gives us like these complex solutions, unless I did something wrong in here. But it gives us this, which I think the first one is the solution. And then it gives us the trivial solution as well. So the only thing we want is this one. And I remember that this one is the correct solution to this. Okay. The ones I gave you guys for homework, they only have real solutions to it. So you guys don't have to worry about that stuff. Okay. Now, if I want to impose that initial value, what I'm going to do is I'm going to define a new variable. All right. So I'm going to say cond for condition, and that's going to be y at 1 double equal 1. Okay. And remember, a semicolon just suppresses the output. And instead of dsolve EQU, I'm going to say dsolve EQU comma cond. Okay. Now, I don't know what's going to happen to those complex solutions, but the real solutions should come out, and there it is. Okay. So that's pretty cool that MATLAB can solve these really quickly. And also, you guys probably don't like me because the one on the test was pretty tough. This one, not so tough now. Okay. If I want to make it nice to print out, okay, what I can do is I can just assign this to a variable. I'll say sol equals for solution. I'll suppress it, and I'll just do an fprintf, and I'll say something like the solution to the DE, not TO, but to the DE. That's okay. All right, to the DE is %s and then /n. All right. %s means %string. Okay. So it's basically just going to print out like text or something like that. And then we're going to say comma sol. All right. So what that's going to do is that's going to print out %s is going to reference that sol in there. All right. And so I go ahead and run this. And there we go. Solution to the DE is this. All right. So for those of you guys that have to do this or something like this at work, or if you have to do it for another class, now you guys can write a really nice piece of code that's going to print this out pretty quickly. Okay. So what's that? So the /n means it's going to go to a new line. Okay. So for instance, check this. That's a good question. If I do like 3 of these and then I run it, then the cursor's all the way down here. So basically it goes enter, enter, enter when it's done. Okay, so it's just the return carrier. Right, yeah, it's just for formatting, okay? That's the way I do it, just to make it nice and formatted, okay? Other questions about this for the first order stuff? Okay, second order, okay, about the same. All right, so let me clear all. And now what I'm going to do is I'm going to define symbolic variables. So I'm going to say sims x, y at x. And then I'm going to define dy to be equal to diff y of x. Or y comma x, okay? And then somebody remind me, the one that was the one variation, or not the variation parameters, the one that was by what's it called? Undetermined coefficients. It was y double prime
minus 5y, 9 plus 4y, 2x plus 1, plus 6e to the power of x.
Gotcha. Okay. And that was probably the hardest one on the exam. All right. So for us to solve that by hand, it's pretty rough. Okay. So let's see if MATLAB can solve it for us really nicely. And in fact, I'll throw in initial conditions to this as well. Okay. So let's say I say something like y at 0 is equal to 1, and then y prime at 0 is also equal to 1. All right. So I wasn't able enough to put that on the exam. I was able to put the first part of it, but not the initial conditions. All right. So what I'm going to do first is I'm going to define the differential. Let me just get the general solution for you guys. Okay, so I'm going to say EQU is going to be equal to diff y comma x comma 2. Okay, now what this does, this defines the second derivative. Okay, so that's the y double prime in that differential equation. Okay, and then minus 5 times diff yx, and then plus 4y. Double equal, and then what did we say? It was 2x, so 2 times x plus 1 plus 6 times exp of x. All right, so that's the differential. I mean, just typing it in, we should probably get like 2 or 3 points just for that. And then the other thing I want to do is I want to solve that. So I'm going to desolve EQU. All right, so let me run this. And that should give us the solution. All right, so that's the first one, not the second one. It's still working on the second one. So this was the solution to the differential. Okay, so for those of you guys that got it, you probably got like, your A was -2, your B was -1/8, okay, and then your C or something like that. Okay, it doesn't simplify it. So what you might have to do is you might have to do a simplify function. So I'm going to define, set that equal to sol, and I could simplify sol. All right, and then so what that'll do is that'll make it a nice simplified representation of that. So let me run it, see if it makes it any better. Probably not, but couldn't hurt. All right, there we go. Okay, so it did simplify it. This was the answer that I got when I did it, and the answer that several of you guys got. So a lot of you guys got your constant to be 7/8. Remember, you had to multiply the e to the x by x. So there's your increased factor, and then the x over 2. All right. Now, let's say I want to impose the initial conditions up there. Okay. So what I'm going to do is I'm going to define a condition 1 and a condition 2. So I'm going to say cond 1 is going to be equal, or cond 1. It doesn't matter what you call it. I'm just going to call it con 1. That's going to be equal to y at 0 double equals 1. And then cond 2 equals, I'm going to say dy at 0 double equals 1. All right. So remember, we defined dy to be the derivative right here. That's where this dy comes in to do that. Okay. So does that make sense, guys? I know I haven't used this yet, but that's where this dy comes in for this. Okay. All right.
I saw in the videos, you appreciate that we can do just 2 columns.
Right, yeah, you could, and that's actually the next line I'm going to do is I'm going to make basically a row matrix of those. Okay, yeah, that's the last thing we have to do is we have to make a final variable cons, and that's going to be equal to a matrix cond 1 comma cond 2. And that's just because when we go to do the solution, it's only going to take one input or one parameter. So I'm going to say cons for there. Okay, so yeah, you're absolutely right when we do that. All right, so let me go ahead and run this. And then I can go ahead and make the answer a little bit nicer. All right, so this would be the particular solution to this. Okay, so what it did was it found 19/24 and 2/3 to be those coefficients. All right, just like we did before, if we want to make this a really sexy output, I can go ahead and say this is sol as well. So sol equals, and I'm going to say f print f solution to the DE is %s and then /n comma sol. I was trying to remember what variable we used. All right, so this should be a pretty nice output. Hopefully, maybe, potentially, feasibly, who knows? Okay, there we go. All right, so guys, any questions I can answer for you all about how you're going to go through and use MATLAB to solve differential equations? Okay, so on the assignment, I asked you guys to solve a couple first orders and then a second order. Okay, so and you guys can use this from now on to solve like some of the problems for homework. If you have like, or at least check your answers. Okay, I don't have any problem with that because we've already done it by hand. Okay, I know that there's one that's on the next assignment, assignment 9, that's really rigorous. If you were to do it by hand, you guys can just use MATLAB to get the solution to it. Okay, it's second order type, that's non-homogeneous. Okay, all right. So the other thing I want to show you guys is how you can go through and plot the solution for a first order differential in a slope field. Okay, and I think I've shown you guys how to use, what is it, Desmos all semester. You guys are probably sick of seeing Desmos. Okay, so now we can go ahead and use MATLAB for this. All right, I have a differential prepared. So let's say we have something like y prime equals 2y over x squared, and I have the initial condition y at 1 is equal to 1. Okay, and 3 things I want to do. Okay, first of all, I want to solve it. I want to plot a slope field. And then the third thing I want to do is plot the solution on the slope field. Okay, and this is, I think, the last question on your first MATLAB assignment. I might have 2 of these for you guys to do. The good news is, though, once you've done one of them and got it to work, you literally have to change like 2 or 3 lines. Okay, so it's not that bad once you guys see the code for this. All right, so let me go ahead. Now I'm going to do a clear all, and I'm going to CLC. Well, I don't need to do that. I'm going to define, now check this. I'm going to define capital X, X, and Y at X. Okay, the capital X is going to represent the actual solution, because what's going to happen is we're going to define lowercase x to be the domain of the slope field. Okay, so there's 2 different x's here. You have to define them both to be symbolic. Okay, otherwise it's not going to give you the right answer for this. All right, once I do that, what I'm going to do is I'm going to plot the domain. Okay, so let's say I want to plot this. Let's say I just want to plot this guy over the domain from like 0 to 4 by 0 to 4. All right, so let's just go like for our x, y, basically 0 to 4, 0 to 4. That way we have like some sort of constraints. Okay, what I'm going to do is I'm going to make something called a mesh grid, and I'm going to show you what this does for those of you guys that care. So mesh grid, and I'm going to say 0, 0.2, 4, 0, 0.2, 4. All right, now let me show you what this does, and let me suppress all this other stuff up here. All right, that way we don't need it because we're really just focused on this. All right, I want you guys to notice that it just makes a matrix of values. Okay, so basically you're just going to have like a bunch of ordered pairs. Okay, so what this really just does is a bunch of ordered pairs for anybody that cares. All right, so now what we can do is we can actually make a grid that has all like the vectors on it by this. Okay, I'm going to define the differential equation. Okay, so I'm going to say, I'll just call it y prime, and that's going to be equal to, now we have to be careful when we do this. So this is our differential equation, but I'm going to say 2 times y dot divide and then x dot squared. All right, now I know some of you guys have used MATLAB before. For those of you guys that use MATLAB, why am I putting dots in here? Does anybody remember what that does?
So you can divide all the order pairs.
Yeah, whenever you, it's basically matrix operations, okay? Whenever you have a dot, okay, you're actually doing operations on this matrix down here. That's what it is, okay? One thing, guys, it never hurts to use a dot, okay? So if you want to use a dot for any multiplication or division, you can, and it won't do anything bad to the function. But that's what we want to do to make this work, okay? So right before any division or multiplication or exponentation. Now with the 2, you don't have to do that because it's a constant, okay, or it's just a coefficient. But if I were to do this 2 dot times, it's not going to hurt it, okay? In fact, I can run it. I'm going to unsuppress this and just show you what happens when I run it. Okay, so now what happens is I just get a bunch of ordered pairs. Okay, so, and I get an infinity because right here, by the way, how come I get infinities at the beginning here?
0.
Divided by 0, right, guys? Okay, so if you get infinities, that's okay, because sometimes you're going to be divided by 0. Okay, so don't let it scare you. It won't bite you too badly. All right, now what I'm going to do is I'm going to start getting those angles, okay, or the vectors, okay? Now you guys probably remember like an x coordinate, a y coordinate for like when you're plotting a vector, but you can use the arctan function, okay? So I'm going to define theta to be the arctan of y prime. And what that's going to do is it's going to create a bunch of angles for us for those vectors. Now, what I want to do is I want to plot the x and the y. Okay, so remember the x is going to be the cosine. So I'm going to say u is equal to cos of theta. And I'm going to say v is going to be equal to the sine of theta. All right, now these are all the ordered pairs, and these are going to be our vectors. This 0.2 right here, that's actually going to tell us the length of the vector. Okay, so if you want longer vectors, change that to 0.3 or 0.4. I'll play around with that in a few moments just to show you guys what changing that parameter does. Okay, all right. Now, I'm going to go ahead and just, oh, I haven't plotted it yet, but let me go ahead and I'm going to say figure. I'm going to say figure 1 just because I can. I'm going to say quiver x comma y comma u comma v. All right, and let me just run that to show you guys what that does. It's going to create an image, I think. I hope. Maybe there it is. Okay, so that's our slope field. Okay, and notice it only goes from 0 to 4. Okay, I know it's tough to see up here. I promise this is 0 and 4. Okay, no, does that say 0 to 4? Yeah. Okay, so you trust him. He's up front. He's got glasses, so he definitely can see it.
Sometimes.
Yes, maybe me too. If I didn't have my contacts in, you could throw whatever you wanted at me. So yeah. All right, so that's how you guys get the slope field. Now, what we want to do though is we want to plot the solution on there. All right, so here's the trick. All right, we are going to find the solution in another file. Okay, so this is tricky, but it's easy. We can find the solution. All right, so I'm going to open up another file. I'm going to do a CLC and a clear all.
So for figure,
Mhm.
I'm wondering, is it just naming the tab?
Yeah, right. So for instance, there's a couple other problems where I'm going to ask you to plot functions.
Yeah.
So you might call this like figure 4 or figure 5. Okay, so it just goes sequentially in order.
Yeah, I did this at home. I just didn't know how do you snap also the tab into, because on the side where the graphs are.
Oh, over here.
Yeah, I was having trouble trying to snap it. Into
Oh. So what you're going to do is like it'll just come over here. Now, when you say snap it, you mean like get like
as in like for me, it's like a whole separate kind of I guess thing from MATLAB.
Yeah, and what will happen is when you guys send me the code, I'm just going to run the code. You don't have to do
so it doesn't
anything.
matter.
Right, yeah, because I think some of you guys might save it as like an ASV file or something. You don't have to do that. Just send me the .m. I'll run it. And that way, like if I see like any sort of inconsistencies, I can like fix it really quick, or I could just omit the code. Okay, that way. Okay, but good question. Thanks. All right. So what we have to do to be able to plot this is we have to go back to, and we're going to clear all, and we just have to solve the differential. Okay. So remember, we need a sims, and I'm going to say x, y at x, and I'm going to define our EQU to be this animal right here. Okay, so 2y divide x squared. And I'm going to say that's the derivative. So diff y at x double equals. And then we have our condition, right? Our condition was equal to, what was it? Y at 1 equals 1, I think. Okay, thanks, guys. And then I'm going to desolve EQU, comma, CUND. All right, now I'm just going to run this because I need to get the solution. And I'm going to save it. You might have to save it as something else. I'm going to call it, oh, yeah, it's fine. All right, so it's going to run it. Okay, here's our solution. All right, now what I'm going to do is I'm going to copy and paste this. So here's the trick. Copy and paste it. And I'm just going to call this over here, solution equals. Now see this X, I'm going to change this to a capital X. Okay, so all the X's you're going to change to capital X's in the solution. All right, because I don't want to use the small x because the small x is assigned to the mesh grid. Okay, so I need to differentiate those two. If you want to use a completely different letter, that's fine too. Okay, now I'm going to plot that solution on the same graph. Okay, so what I'm going to do is figure 1. I'm going to do the quiver. I'm going to do a hold on. And then I'm going to do easy plot of our solution. And I'm going to suppress the solution. Okay, so easy plot the solution, and I'm going to hold off. All right, so let's run this. Hey, there it is. All right, now that's bad, right? All right, what we need to do is we need to define the domain of the easy plot function. Okay, so what we're going to do, one last thing, is we're going to say comma. We will go by 4 by 4. So 0, 4, 0, 4. Right. And then I'm going to run this one more time. Hopefully that looks better. It couldn't look much worse than what we have here, right? There it is. All right. For those of you guys that are close enough to see, does that look like it fits the curve? Absolutely. Okay. You guys can clearly see it kind of flows right through there. Okay. So
one more question. So for the quiver,
Mhm.
I'm wondering, does it basically, I guess, for the hold on, hold off, how do you know the quiver is going to go on that graph specifically? Not
So-
the other?
yeah, so what I did was I defined a figure.
Yeah.
So that starts a new image.
Oh, okay. I see.
Right.
Yeah.
Yeah, so that makes it defined.
So anything under that is okay.
Going to be in the hold,
Yeah,
right? And then
that's-
once I put the hold off, and then when I start a new figure, that's when it's going to do something
Okay,
different.
I see. All right.
Okay. Guys, really quickly before the alarm goes off, what I did was I changed this parameter to 0.1. So that should make all of our vectors a lot smaller, which is good and bad. Okay, so we should get a more fine graph. Maybe. Yep. But at some point it becomes unuseful, right? Because at some point, if these get too small, then it's just like a big old block. Okay. And then also if I make it too large, like a 0.4 and run it, then it really doesn't show the contour of the vector field or slope field or this thing. All right, there you go. I mean, it's still okay, right? But I think 0.2, this is just my opinion, okay? And you know what opinions are like, but just from my experience, I think 2 or 0.2 is probably the best we can do with this, okay? All right, so I'm going to stop this because I know